So in this video, we're going to make a connection between the idea of particle abstraction and the idea of momentum. We've sort of thrown around this sort of idea that if I've got some complicated object that's rotating and moving through space, that it kind of makes sense to imagine taking this complicated object and compressing it down to a point and just asking the question, how does that point mass move around in space? Well, momentum ends up being pretty helpful for actually figuring out where this point mass is located, how fast it's moving, and what the mass of it is. Okay, so what we're doing here is deriving center of mass, right? So we want to come up with the idea of center of mass, but I want to come up with that idea of center of mass in the context of actually thinking about this idea of abstracting from some extended body to a particle, because it's an abstraction we've actually been using a lot. We've said, oh, well, let's just imagine that it's a particle. Why can you actually do that? Right? And the gist of why you can do it has to do with this idea that we're looking for some equivalent particle. So we want an equivalent particle to this extended body. Well, what does it mean for it to be an equivalent particle? Well, pretty clearly one thing that it means for it to be an equivalent particle is that it should have the same mass. Right? To the extent that mass is a conserved quantity, if this is equal to that, it seems like the masses ought to be the same. It wouldn't make very much sense to abstract something that was 10 kilograms into something that was 1 kilogram. It also should have the same momentum. And that would mean that it's going to obey the same equations of motion. And finally, it should have a position that sort of makes sense with regard to what the position of this is. Like if you actually imagine taking this thing and abstracting it down to a particle, it somehow seems kind of wrong that if this is the thing, that the particle would be over here. It sort of seems like somehow that particle ought to be located, co-located with the actual thing that you're abstracting it from. So I'm going to say same position in quotes because, of course, this object doesn't have one position. It consists of a whole bunch of stuff that's sort of spread out in space. Okay. Well, in order to do that, what we're going to introduce is the idea of the center of mass of the object. So I'm going to introduce RCOM, which is the position vector for the center of mass. This is the location of the equivalent particle.